Okay, next one. First and foremost, quotient rule. So let's start with quotient rule. Plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the plain denominator squared. Quotient rule. Plain denominator, derivative numerator, plain numerator, derivative denominator, plain denominator squared. Now next we're going to use that the derivative cosine inverse of u is -1 over the square root of 1 minus u squared du dx, with, in this case, u equal 3x. That you have to learn these formulas. So, plain first, leave it alone. Then, -1 over the square root of 1 minus u squared, where u is 3x, then the derivative of 3x, 3. So where that 3 came from, that's the derivative of 3x. I'm up to that minus sign, so then minus, then cosine inverse of 3x times 1 all over x plus 1 quantity squared. And there's my unsimplified derivative. Now we are going to simplify it. I'm never going to accept something that looks that nasty. So starting to simplify this. So that first guy up there, that's going to be -3 times x plus 1 over the square root of 1 minus 9x squared minus 3 cosine inverse of 3x over x plus 1 quantity squared. Can't see all that. Let's move that up. There, you can see that better. Then I don't want that complex, that compound fraction. I do not want a fraction inside of a fraction. So I'm going to multiply all terms by that square root of 1 minus x squared, or it's really square root of 1 minus x squared over 1 to keep things lined up. Move my equal sign a little bit. So doing that, square root of 1 minus x squared times 1, square root of 1 minus, square root of 1 minus 9x squared over 1 times the square root of 1 minus 9x squared over 1. That has the effect of killing off that fraction, which is what I wanted. Then I can distribute that -3, so -3x minus 3. And on the next term, there's really nothing I can do there, except to write those guys beside each other. And then down below, nothing I can really do except write the things beside each other. And there's my simplified derivative. There is nothing else I can do. Nothing cancels. That's it. Okay, so that was our practice with sine inverse. And then we had a cosine inverse. So moving on to dealing with tangent a little bit. So find the derivative of tan inverse. And so we're going to do it the same way we did before. If y equals tan inverse of x, then tan x equals y. And so we will use implicit differentiation on tan, or y equals tan x. We'll put the y on the other side. Okay, y equals tan x. Derivative of y is 1, but I just differentiated. I got these backwards. Sorry, made a mistake. I'm not going to start. I'll just white it out instead of completely killing the video. We'll just get it right. This is going to be tan y equals x. Got those backwards. And so then this becomes, still making a mistake there, tan x. Still making the exact same mistake again. We'll get it right here. Then tan y equals x, or we're going to do tan y, x equals tan y. Tan y equals x. There, we got it right. Took a while. Again, if I wasn't so lazy, I would have stopped and gone and redone the whole video and whatnot, which I have done when I make big mistakes, so you never see the huge mistakes, but little mistakes like that, we're just going to white them out and start again. Because everybody makes little mistakes. You don't need to start over with a little mistake. Just correct it and then continue. Okay, so tan y equals x. Implicit differentiation, derivative of tangent. Y would be secant squared y, but I just differentiated y. So dy dx, derivative of x would be 1. So we have dy dx equals 1 over secant squared y. But again, that's not what we're going to memorize. So tan y equals x, which is x over 1, which is opposite over adjacent. There's my angle y. Opposite, adjacent. Pythagorean theorem would give me the square root of 1 plus x squared. All we did there was the Pythagorean theorem. And so secant y, which is hypotenuse over adjacent, becomes 1 plus x squared over 1, or square root of 1 plus x squared. Or just 1 plus the square root of x squared. So taking that back over here, and then squaring it, and so we can bring that value right back over here. And so we get the derivative of tan inverse is 1 over the quantity 1 plus x squared. Again, there I figured it out. You don't have to memorize how to figure it out. You don't have to figure it out. You just have to use it. And so more generally, where u represents a function, the derivative of tan inverse of u is 1 over 1 plus u squared, du dx. And if we happen to do cotangent inverse, same thing, just negative 1 over 1 plus u squared du dx. So let's do a problem. Tan inverse of the natural log of 3x. So we are going to use that the derivative of tan inverse of u is 1 over 1 plus u squared du dx, with u equal the natural log of 3x. So I just start applying the formula. And so you've got to memorize these formulas. And I forgot to write down here, memorize. You need to know these formulas. So back over here now, using my formula, 1 over 1 plus u squared. But u is the natural log of 3x. Then times the derivative of the natural log of 3x. So 1 over 1 plus the natural log of 3x, quantity squared, then 1 over the argument, derivative of the argument. Those 3's cancel. And so I get 1 over x times 1 plus the natural log of 3x, quantity squared. And there is no other simplification you can do there. Okay, let's do the next one. Same thing, really. Use the derivative of cotangent inverse is negative 1 over 1 plus u squared du dx, with u in this case 2x to the cubed. So y prime is going to be negative 1 over 1 plus u squared, but u squared is 2 raised to the x cubed, then times the derivative, 2 raised to the x cubed. So we've got negative 1 over 1 plus exponents to exponents, you multiply. So 1 plus 2 to the 2x cubed. Exponents to exponents, you multiply. You're multiplying the whole exponents. It looks, a lot of people want to say 6, but you're multiplying the exponent x cubed times 2. X cubed times 2 is 2x cubed. Then that derivative in there, and so we remember our words that it repeats. Natural log of the base, derivative of the exponent. Repeats. Natural log of the base, derivative, exponent. And then there's not much you can do to clean this up. There really isn't. I put a negative sign in front of it, but then 2 raised to the x cubed, natural log of 2, 3x squared, all over 1 plus 2 raised to the 2x cubed. And there's a little game you could play in here if you wanted to, that this is the same thing as 4 to the x cubed, but there's nothing particularly good you could simplify, so we won't. There is our answer. And so again, these problems look really complicated, but if you remember your formulas and remember your words, you can work your way through them. But you've got to memorize the formulas, you've got to memorize the words. That once I knew the formula, apply my formula, then the words that describe the 2 raised to the x cubed, it'll get you through them, but you've got to memorize some stuff. We'll end this video.